Okay, we're into the gases chapter for AP Chem, and again, you've seen this in regular Chem, but we're just kind of reviewing it. So a couple of things today we're going to kind of go through pretty quickly, just, what is a gas, how does it act, what's the pressure, that kind of stuff. So some things about gases you should know, that most elements don't exist as a gas naturally. There's very few things that are just naturally gases. And all of the ones that are nonmetals, and they're going to have a really small molar mass, which means that the actual individual molecules or atoms are small. You want to remember that the volume is not set. They can change. You can compress gases. You can expand them. So keep that in mind. And they can mix with any other gas. There's not like, you have the thing with liquids where like some liquids won't mix. Gases aren't like that. They'll mix with any other gas, and there's not really an issue with it. Oops, let's try that again. All right, so keep in mind that part of the reason that gases act the way they act is that their atoms or molecules are really far apart. Even though you're sitting in the room breathing air, only the actual molecules only take up 0.1% of the actual space. So the molecules are very far away from each other. They don't really know that the other ones exist, so that's why most gases act the same. And the big thing we look at with gases usually is pressure, and you just want to keep in mind if we actually look the thing of pressure, and we want to have a little formula for it, pressure is going to equal, not plus, equal, our force, how much something's pushing, over our area. So how hard is the gas pushing on a certain area? If you blow a balloon up and it's really full of air, the pressure is pretty high. There's a lot of things pushing on the area of the balloon. So just keep that in mind. So, definition of pressure is the force over an area. And it's the gas molecules actually striking things. They strike with a certain amount of energy and it has a certain amount of force. And you want to remember that we measure it with barometers. And remember, you have this thing here that's open, and the atmosphere is pushing down. And what happens is that mercury is under pressure, and it's saying, okay, what can we do to alleviate that pressure? And what it does is it actually goes up the little tube. And remember, there's no air above the mercury. And this height over here, the height of this mercury column, is going to actually tell us what the pressure is being exerted. The harder the atmosphere pushes down, the higher that mercury is going to go. If we're looking at the SI unit, it's called Pascal. Pascal is actually pretty small. It's a pretty small unit, so we usually use kilopascals, but that is the SI unit. We do have the standard atmospheric pressure, usually 1 atm, that kind of stuff, and that's the stuff that we're used to living at. And normal sea levels, so if you're on the top of the Himalayan mountains, it's going to be different. The big thing that you probably maybe remember or should remember is that there's a million different ways to actually show pressure. And this is not all of them. In the book, there's more, and on your homework, you're going to have to look in your book because I think they ask for like bars and stuff. So there is a lot of conversions for pressure that you need to be familiar with, and these all just equal each other. So 760 millimeters mercury equals 101.3 kPas, and so on and so forth. So just use them to convert between the two. So if we use these, we can do three quick problems. So the first one, we want to go from 0.357 atms to torr. So we just start off with what we have. We're going to need to make a conversion factor. And there's 760 torr in 1 atm. That gives us 271.32. And that with sig figs is 271 torr. Second one, we want to go from torrs to atmospheres. So we have 6.6 times 10 to the negative second torr. 1 atmosphere is 760 torr. With sig figs, we should have 2, and our answer is 8.7 times 10 to the negative fifth atm. And then last one, we want to go from kPas to torr. So if you look up, we want torr, so that goes on top. There's 760 torr and 101.3 kPAs. With sig figs, we get 110 torr. So again, this is Chem 1 stuff. You should be able to convert. And then we also have these things called manometers, and if you had me last year, you'll remember these. They're not hard, they're just two different things you have to look at. First one is a closed one, and you're just looking at the difference in the height of the mercury. The open ones, you have to worry about atmospheric pressure. So you just have to worry who's winning the battle. All right, so the first one, what you have to do when you look at these is you have to see, is it open or is it closed? We're actually going to do the closed one first because it's pretty easy. So all we have to do is we look at this and say for the closed one all the way on the right, the gas is pushing, and it's just pushing against the mercury. The harder it pushes, the bigger that difference in height is. So if the height is 37 millimeters mercury, that means the pressure that the gas is exerting is 37 millimeters mercury. So say this was 57 and say this was 20. They took the high minus the low and they said, oh, that height's 37. So that's how they got that. And if it's closed, you just need that height difference and that's your pressure. For the two open ones, we have to worry about the atmospheric pressure. So say our atmosphere is 765 millimeters mercury. So they're open, we're going to have to take that into account, and we have our height difference. They already did the subtraction. You may have to do the subtraction normally, like say this was 100 and this one was 45. We would have subtracted those two and gotten our height difference. Now we have to say who's winning. Is the gas pushing harder or is the atmosphere pushing harder in the first one? Well, in the first one, the atmosphere is pushing harder. He's winning. So that means the atmosphere is higher than the gas. And he's going to be the height difference higher. So the atmosphere is 765. We're going to subtract out that 55 difference in height, and that means the gas is pushing with 710 millimeters mercury of force. And you can see that because the gas is losing. He's not pushing as hard. If we look at the second one, the open-ended one, same pressures of the atmosphere. We have our height difference, but this time, gas is winning. So that means he's higher than the atmosphere. So if the atmosphere is 765, this time we're going to add 110. So we add the 110, and this guy is 875, oops, that's really bad writing, millimeters mercury. So you should be able to look at these. Should be able to get the height difference. You should know if it's open or closed. And you should be able to then figure it out. All right, so stop the video. Try the one on your own, work together on it, see if you can get it, and then when you come back, we'll go over the answer. All right, so you're back. Hopefully you have your answer. This one was you had to work a little harder for this one. So they tell you the atmospheric pressure is 764.7, and they tell you the different heights. So if we write these on here, the high side is 136.4, and the low side is 103.8. So the first thing we need to do is just get that height. So we subtract them. We always want a positive height. So we subtract the big guy from the little guy. And we have a height of 32.6 millimeters mercury. Now we have to figure out what to do with it. It's an open one, so we're going to have to take the atmosphere into account. And we know that it's 764.7 torr. So now we say who's winning. Well, it looks like in this case the gas is winning. That means the gas is going to be higher. So you'd have to add them. So you'd have 764.7 plus 32.6. And be aware that the atmospheric pressures in torr, the height is in millimeters mercury, but they're the same, essentially the same thing, so we can add them. You'd have to make sure they were the same first. And when you add them up, you get 797.3 millimeters mercury. And then B is asking you just to convert. If we have 797.3 millimeters mercury, there's 101.3 kPa in 760 millimeters mercury, and that's 106.3 kPa. So those are your two answers.